All right, good morning.
Morning.
Yeah, y'all sneak at this. All right, let's try this again. Okay, so I'm gonna change this up. So now, wait. So I'm recording this, and so you could actually hear yourself later on because I have my microphone right there. So when we are interacting, let's say for instance someone is not here and they're like, "Oh my goodness, I need to go back," and it's almost like sitting in class because you even get to hear all my jokes, okay, and all the funny things that Denny says, which is hilarious. Okay. So anyway, we're gonna start out this. So when I say class, you say yes. Class.
Yes.
Class.
Yes.
Thank you. Good. All right. So we're gonna go through and do this, and so these are referred to as the prerequisites for calculus. It's a lot of vocabulary. So those flashcards that I gave you is going to have a lot of this stuff, and it's going to help you out with this definitions because some of the things that I already mentioned once, like the slope-intercept or point-slope form, those are things that you might not key in specifically automatically, but we're going to go through and do a lot of the stuff. Now, this is a nomenclature. This is a certain way that we identify some of these things. So change in variables, so like from the x1 to x2, is going to be a delta x. Now, delta refers to the change. Okay, what is the difference in between those two? So how far are they apart? So delta is what we're going to use there. Okay, so delta t, delta x, delta y. Okay, red delta. Okay, and it is a capital Greek letter for difference. Make sense? Good. So, and it does not mean times for those people that think that it is like a multiplication in between there. It's not. So it just identifies what it is. So delta means a change in. All right. Example of increments. We have 2 points right here. So with 2 points, I can find the slope of a line, right? Yeah. So there's a couple things. So we know how to find the slope of a line, right? In between 2 points. What's the formula? It was one of your things.
Oh, the point slope formula.
Not point slope. Just slope. What's my slope formula?
Oh, y equals mx plus b.
No, that one's slope intercept.
That's
Okay, y2 minus y1 over x2 minus x1. Okay, refresher. That's why I'm starting with this. I'm not expecting you guys to already know everything. Otherwise, why would I be here? I wouldn't have a job if you already knew everything, right? So, forgive my handwriting, kind of sucks, but you guys are filling in notes as we go, right? Because that's what good students do. And if you do not have something to write with, I have some right here. Anyone? Good. Okay. So this is my Little Pony cup that students gave me, and they thought it was funny. They're like, "Ha ha ha! He's gonna have My Little Pony cup." I'm like, "Ha ha." I know. Joke's on you. I like My Little Pony. Okay. Anyway, so which is also referred to. So if y2 minus y1 is the difference, I could rewrite that. So if it's just asking for the difference, that would be delta y over delta x. Delta y over delta x. That's what that means. So it's finding the slope, which is the change in the y divided by the change in the x. So let's go ahead and put in some points. So y2 is going to be 1 minus 3 over negative 6 minus 8, which gives me a grand total of, so 1 minus 3, negative 2, over negative 14. Then we do this thing called simplify or reduce. So I got two negatives. Two negatives make a?
positive.
Thank you, positive. And then the 2 over 14 will reduce to
1 over 7.
1 over 7. Okay. So, refresher. Okay? All right, variable of a linear function, okay, that the change is going to be a constant. It's not going to vary. Delta y over delta x is going to be a constant. Constant means it doesn't have a variable. It is a number. It's no longer m, it is whatever number that goes with that. All right, change constant increment slope of this line. There we go. Slope. We just did that one for that previous problem right here. So rise over run is also referred to as m in a lot of my formulas. Delta y, delta x, y2 minus y1 over x2 minus x1. Yes? Hopefully. Slope of a line, just like what we got done doing here in a minute ago. Okay, a line with the slope of 0, that means my delta y is 0. The slope is 0 when my delta y is 0. So that is a horizontal line. A vertical line has no slope, and that is special. That means my delta x is 0. But there's a problem with that. Why would it be a problem to have delta x be 0?
Delta X.
Think about it. Think about your fraction.
Oh, because it would void or, no, it would just.
It's undefined. Very good. Give yourself a high five. It is undefined. Okay? You cannot divide by 0. 0 in the denominator of a fraction is undefined. That is super important because when we're doing these problems, and especially when we get to the calculators and you're doing some math and you plug it in and you get something that says undefined, you need to think, oh, it's undefined because that is what type of line?
A vertical line.
A vertical line. Okay? That's super important there. So, point slope of equation. There we go. So this is also another way to do this. So this is your calculator ready. Now, this x sub naught, y sub naught, it's a physics term that refers to your initial point. X sub 0 or y sub 0 is your initial point. Okay, wherever your starting point is, that's where you're going to have. We're going to have a lot of problems like this when we're actually doing like cooling or half-lives, where there is a exponential, a linear, or a logarithmic function where we're trying to find the half-life of some radioactive isotope. We're doing it mathematically, but we have to start somewhere as it starts to decrease for the half-life. So we have to have a starting point. Point slope of equation of a line. Find the point slope equation of a line with the slope of 5 that passes through that point. All right, on your paper right now, fill in what your point slope is going to be. For that one, yeah, we're right there. Did I not give you the notes? They're filling in them, so you're right on it. All right. You just wanted to be extra. That's what it was, right?
What? Okay, I guess.
Hey, you know what? We just have extra people sometimes. All right, so there's two ways of writing it, point slope. So it'd be y minus 3 equals m, which is 5, quantity x minus 2. This is my regular form. And then there's the calculator ready form, right? The calculator ready was y equals, it would be 5, quantity x minus 2, close, and I believe it would be, is it plus 3? because calculators don't normally let you enter things on both sides of the equation. It's usually just a y equals or a function, f1 equals, right? So you can't have y minus, in this case, y minus 3, right? You can't have that. So the calculator ready is another way of doing it, so you could put it in as you see directly on your paper into the calculator. Equations of horizontal vertical lines. A horizontal line has a slope of 0. That's where my delta y equals 0. That's important. So this is my delta y equals 0. Okay, equation right here, it looks like this. And if it is plugged in accordingly, it's y equals b. And b is this number right here. It's the y value. That is going to be my horizontal line because it's a flat line, and wherever it crosses the y-axis is where that goes horizontal, all the way across. Vertical line is the kind of opposite, so it means it goes up and down, but this one has an equation of x equals a, where a is the value right there of my x value. Whatever my x value is, it's going to be a line straight up and down right there, and we know that it has no slope. That's where my delta x equals 0, or also known as undefined. Slope-intercept equation and general linear equation. So here's my slope-intercept. We talked about this a little bit already. Y equals mx plus b. Y is the intercept. I'm sorry, b is the y-intercept, b is the y-intercept. General equation is here. This is my ax plus by equals c. Now, whenever it's in that form, this is also referred to as standard form. A and b are not both 0, and a is positive. There's one more thing that goes along with this. They can't be fractions. They can be whole numbers, integers, but a has to be positive. B could be positive or negative. So what you would do if you get a fraction is you multiply the whole thing by the common denominator to eliminate your fractions. So you're going to get bigger numbers, and it's kind of a pain trying to deal with this one, but it is an important form because you will see this. So ax plus by equals c. C is going to be the constant, which eventually comes out to be like important because it's not a variable. It's going to be a constant. C, by the end of the semester, you will remember to put plus c on everything. Plus c on everything. At the end of the semester. Not at this point. You can't plus c it yet. All right, here it is right here. So, at this point, 0b. B is the height away from my x-axis. Okay, where 0 means that it's going to be right on the y-axis. Okay, y equals mx b, blah, 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 slope is m. Parallel lines, same slope. That's important. Parallel lines have the same slope. Parallel lines have the same slope. But they have to have different intercepts. Because if they have the same intercept, what's going to happen if they have same slope and same intercept?
It's just views.
It's the same line. So it's the same line. So that would mean that they intercept or they touch each other at all real points. Every single point they're touching each other. You guys have siblings?
No.
Okay, yeah, you have those siblings that are like super annoying and they're like, you know, stop touching me. And they're still touching you, or they're like all up on you and you're like, stop touching me. Kind of like that, okay? They're touching you all the time at every single point. And that is when you get the exact same line. All right. Okay, so lines equal slopes. If your angle, blah, blah, blah. Ah, crap. Ugh. I lost my thingy. There we go. Same slope, parallel lines. This is the fancy verbiage for this. Yeah, symbol for parallel. Okay. And another thing which will come up later, but at this current moment in time, I'm not worried about this. Theta 1 and theta 2 are going to be the same angle. So if this is 45 degrees, this is also 45 degrees. And if I was back in geometry, this angle right here, and L1 and L2 are parallel. Can anyone tell me what is the special name for these two angles? No, not interior.
Oh.
Parallel lines cut through a transversal. My transversal is line X.
No, it's not alternate.
Hmm? Alternate X here? No, they're not.
Oh my god.
Here's a hint. They're not alternate. Are they on the same side of the line?
Yeah, they're on the same side.
So, all right. So anyway, these ones, it's not going to be on the test or even in the flashcards. It is consecutive interior, or I'm sorry, nope. Corresponding angle, sorry. No, because there's two names for it, and I'm not going to use the other one. So it's alternate, consecutive. It's some weird thing, but yeah, I'll just use like the basic corresponding angles. Corresponding angles are angles that are on the same side of my transversal, but one's inside, the other one's outside. Inside would be between the two parallel lines, and the outside would be not between. Okay, anyway. Perpendicular lines. Perpendicular lines are perpendicular slopes M1, M2 satisfy that it is gives you -1. That's kind of weird. I don't like that. I don't like that. So let's just say it's opposite reciprocal. Opposite and reciprocal. So here's an example of opposite reciprocal. If I have a slope of, so if M1 is equal to 2 over 3, line perpendicular would be what? Say it one more time. 3 over 2, close. There's an and right there. Is 2 over 3 positive?
Yes.
Yes. If 2 over 3 is positive, the opposite of a positive is a?
Negative.
Very good. So it's going to be a negative, so it's opposite and reciprocal. So that means that this one would have to be a -3 over 2. Better? Does that make more sense now?
Yeah.
I'm hoping. So I'm throwing about a whole bunch of words out there. We good? Okay, good. All right, so I think this is the point where we got a whole bunch of other stuff. How many more slides do we have? We got a bunch, don't we?
One.
Yeah, we got a bunch. So I'm going to stop right here. So I'm going to leave off here. Now, again, your homework for today is not the PowerPoints or any of that other stuff. It is going to be your flashcards. Okay, so now I'm going to stop the video here. So make sure you all like, share, and subscribe. Hit that notification button. Support my channel by buying stuff from my merch store. There you go.